Okay. Hi, everyone. If someone can keep an eye on the team space, because I can't see the chats anymore, just in case anything comes up. Yeah, so this is a talk that I've been thinking about giving for like about 2 years since AI entered our workplace or infiltrated our workplace. And I've only sort of just got the confidence and enough like anecdata to like feel like I can talk about it in front of people. So let's go. What I'm going to go through today is like why this matters, a few definitions and introduction. I've got like 3 failure modes that I've sort of classified and some recommendations for what to do. So these failure modes: garbage in, garbage out, blind trust, and over automation. I've got a little extra slide on SPSS because I don't talk a lot about it, but I know some people will be in the SPSS world. And just to wrap up. So why does this matter? As many of you will know, you can now generate like a full analysis pipeline in 30 seconds. You can literally say, here's my data, analyze it, and you can get tons of code, tons of graphs, lots of stuff pretty quickly. It's pretty exciting. I've been talking to people and people are saying there are research questions that were just out of scope for me a few years ago. Too much coding, too much, like that's all too slow for me. And now I can imagine I could do one of those big global ecology studies because the coding is much more accessible and much less time consuming. So that's exciting. And yeah, it's like kind of like moved this question of like, can you code to whether you know when your code might be wrong. So just today, I'm using these terms AI, chatbot, or LLMs, large language models, a bit interchangeably. And I'm sort of like saying this because, you know, some definitions of AI, they extend all the way to the humble linear model. So statistics, all of statistics, it's sort of like a form of AI. But really today, what I'm talking about is ChatGPT, Claude, Copilot, that's your AI. Now, to start with, like, let's just go over some ground rules, because I realized I said this is a talk what every researcher should know. And I can't really talk about the more ambiguous grey areas until we sort of like talk about the ground rules. The first one is data confidentiality. That nothing's changed here. You need to handle your data with the confidentiality required, which is different for different data sets. And that is certainly true, still true. You need to be operating within your university's policies. So if your university says you can't put your data in to this thing unless it's this level of security, do that. You need to be acknowledging the use of AI and maintaining reproducibility. So I don't know if maintaining reproducibility is that's more of a second level ground rule, but I'm going to put it as a ground rule. So what I mean here is that if AI has done an analysis for you, you need to be able to reproduce that outside of the AI. So like you need to be able to run R code or follow SPSS prompts, menus, or in Prism, do the analysis without the use of the AI. And this might seem obvious to some people, but it is actually possible to chuck a data set into AI, get a p-value, get a confidence interval with none of the intermediate steps visible to you. And I've seen it done. And I've asked, where did that number come from? And the only thing that that person had to show me was a chat history. and we couldn't get that number with any other software. So just that's a ground rule, is to maintain reproducibility. So what's AI good at, in my opinion? It's very good at explaining concepts. It's very good at generating code quickly, very good at debugging syntax, commenting code, explaining code, and drafting workflows for fairly routine analyses for which there's lots of training data. So by that, maybe an ANOVA or a linear model with relatively uncomplex study design and stuff like that. And I don't have much experience with this, but I'm told it's quite good at translating between software ecosystems, as long as those are coding ones, I think. So, but what it is not good at doing is understanding causal logic, like understanding study design, reasoning about scientific goals, making judgment calls, and drafting workflows for more unusual analyses. Like, so if your study is a little bit outside the box, there's not a lot of training data, it's more limited in its accuracy in generating responses for you. And it's also not good at recommending good approaches which may not be popular. So it has a popularity bias. And it's not great at detecting like subtle methodological mismatches. So it's almost there, but there's something subtly wrong. And I don't think it is very good at going into that space. So yeah, I think here it has a bit of a complexity bias. It leans towards making things more complex than they need to be, more complex than maybe you'd get if you came and saw me or someone else. Yeah. So this is sort of bit of a fun bit of the talk, where this is how it differs from your human statistician in a number of ways. So your AI is available for you instantly and it never sleeps. That's why everyone's using it. It's just there whenever you want it. Your human statistician takes 2 weeks to books, and I occasionally do answer emails. Yeah. So your AI will explain confidently. Your human statistician is often appropriately uncertain. Your AI, great question. Here's an analysis. Your human, this design is fundamentally confounded. You can't answer that research question. Your AI writes code rapidly. Your human statistician, that is your job, and here's a link to our upcoming courses where we'll teach you how to do it. That's an actual link if you want that. Your AI is predicting text, not truth. So it sounds like it understands your data, but your human statistician, he or she is applying statistical logic and actually tries to understand your data. Your AI might tell you to use this package, library statistical magic. Maeve is never going to give you code that just doesn't exist. So, and this is the final one. Your AI doesn't take responsibility for incorrect advice. I think this is one of the most important ones. It expects no credit. In fact, Claude said on your authorship question, that's a thoughtful and considerate thing to raise, and I appreciate it. But I'm Claude, an AI assistant made by Anthropic. I don't have authorship expectations, institutional affiliations, or any interest in being credited. So please proceed without any concern on that front. But Nixon, he has to explain it all to reviewer too. So that's sort of the accountability aspect. So, okay, so let's go into the meaty stuff, the 3 big failure modes, which are garbage in, garbage out, blind trust, and over-automation. And how to address these: prompting better, verification, and keeping humans in the loop. So garbage in, garbage out, it's an old maxim, equally applicable here. These responses are only as good as the context you're providing. So they're not going to be as useful if you're vague. Your research questions are ambiguously posed. Your prompts are leading. Like you could ask it, how do I get these p-values smaller? And it will help you, but it wouldn't be a great scientific endeavour. And you're missing study design details. And also, like, if you don't prompt for important kind of stuff that you might need to validate the methodology, it might not give it to you, like model assumptions. Can I even do this kind of model with my sample size of 6? Stuff like that. And you should ask for references and things like that. So we can kind of get better at the garbage in, garbage out failure mode by prompting better. Poor prompts are very unique, I think. They're all poor in their own way. This is just a silly one, but you can do this. Here's my data, analyze it. No context, no description, and it goes and it does lots of stuff. But a better prompt is going to contain your research question, really explicitly stated. And can I just say, the reason why I feel like I have such a good understanding of what a good prompt is for in a statistical context is because this is exactly what I would want to know if I was going to give you any statistical advice, all of this stuff. Study design, dependent variable, independent variable. Are you hypothesizing any interactions between your independent variables? Do you have a repeated measures structure, some kind of hierarchical sampling design? Is there missing data, and what are all the features of that missing data? What's your sample size and all the sample sizes of the different levels of your data? That's all very relevant when you're coming up with a methodology. And then you want to ask, what are the assumptions and how do I check them? And also get some links, I'd say, to stuff that's published. And also request a reproducible workflow. So don't just ask AI to do it, but ask it to give you like the workflow that you might implement somewhere that you can reproduce. So here's just an example of what is a less good prompt. And I'll show you why it went wrong. So I'm analysing tumour growth in mice. We've measured the tumour size in 6 mice, 3 treatment, 3 control over 30 days. So this is actually inspired by someone who came to me a few years ago at Stat Central. And I can sort of remember their study quite well. So one mouse was euthanized on day 22 as its tumour growth triggered ethical euthanasia. So what they did was they gave the mice cancer, and if the mouse got too sick, they had to euthanize it under their ethical sort of protocols. And that happened to one of the mice. Tell me how to compare the mean tumour size and body weight for the 2 groups on day 30 with the mean tumour and body weight for the 2 groups at baseline. And they also said, oh, look, we normally test for normality first, and if it's violated, we do a non-parametric version of a t-test. Yeah, and this is like a really pretty much what these researchers, when they came to see me, said to me. So the thing that's not so great about this as an AI prompt is there's not a lot of context around the research question. It just says, I am analysing tumour growth in mice. That's very vague in a statistical sense. The study design is also a little bit vague. When did they measure things, stuff like that. There's some leading questions leading it towards a particular method. And there's no description of variables and their nature in this prompt. So Claude, this is edited because you know these LLMs, they always give you so much text, but these are like the important details from the response from Claude. And I don't expect you to take all of this in, but the first thing Claude told me to do was handle this missing mouse that we had to kill on day 22. And it said, like, let's decide your approach to that mouse. And it gives me 3 options. And the first one is exclude entirely. So just delete that mouse. And it says this is the most common approach, just note it. And so for a simple mean comparison, most researchers exclude it from the day 30 analysis and note it explicitly in the results. You'll have n equals 3 versus n equals 2 on day 30. And then it gave me some other stuff and then ultimately told me to compare the treatment versus the control on day 30. And I might do an independent samples t-test or a Mann-Whitney test. And then also compare day 30 versus baseline within each group. So do a paired t-test. Now, I don't know my audience very well today, but I hope that all of you are doing some stats. And I've picked an example that's like very introductory level stats here. Because an independent samples t-test of the treatment versus control on day 30, that doesn't quite get at my research question, because I'm actually wanting to know, did the tumours grow faster in the treatment group versus the control group? So for that, I usually need a treatment by time interaction. And it hasn't really identified that in its approach. And it's also just told me to delete my missing data. Now, I'll tell you why deleting the missing data is a really bad idea. And this is simulated data. This is no one's real data, but it's kind of similar to the real data in that I've got these 3 mice. The blue mice all got the treatment and their tumours are growing. And one of them's cancer is just out of control. And we had to euthanize it once it reached some kind of level. You can tell it's simulated because these numbers are just completely garbage. But yeah, and so we get rid of this mouse here that my mouse is on. Our treatment is going to look so much better because we're excluding the mouse that had a really poor outcome. And that's what Claude told me to do. So I tried to fix this prompt in a subtle way. And I did all of this with the LLM in incognito mode, so it can't see my chat history. So in the bold text is the stuff that's different. So on the first line, I just added in the word repeated measures. So we've measured this data, it's repeated measures. This is a statistical keyword, and I just threw that in. I added in this context, I want to know if the treatment slows down tumour growth. So that's getting more into the context of this study, why we did it, what's the research question. And I added in some description of the variables. So they're measured in grams, millimeters squared. These are positive definite variables. They can't be negative. They don't seem to be normally distributed because positive definite variables often aren't. They seem to have a bit of skew. And then instead of that leading question about t-tests, I said, what analyses could be appropriate? So this prompt is better because I've got more context about the research question. I've got more description of the study design and the variable types and non-leading questions, but I did drop in a statistical keyword, which is repeated measures. So the thing about leading questions is that it is okay to lead the AI to your method if you're sure that's the method you want. So if you've already decided and you've used your brain to come to this conclusion, and that's fine. I think you can use leading questions, and it's a good idea. If you're like, I want to do this kind of model, you ask the AI how to do that kind of model. You don't want it to muck around doing other stuff. But if you're like not sure what you should do, should be very careful about leading it to a particular thing. And ultimately, this is the response. This is also edited quite a lot. But the sort of key details of this response from the better prompt is that it did tell me to do basically what I would have told someone to do if I'd got that research question and data proposed to me. It told me to do a linear mixed effects model. It suggested a log transform. It identified that you've got this time by group interaction, which is the primary thing that matters. Do the trajectories differ? That's what's going to tell me that. Yeah, we've got random intercepts to account for baseline differences between mice. And it's like, you don't actually need to worry about missing data because you're using a linear mixed effects model, which just does that for you. So it's quite good. And then it does also mention what a tiny sample size we have here. It suggests that we could just do some plots. All of this is pretty sensible advice, I'd say. I wasn't unhappy with anything that I got here. And it was very minor tweaks to the prompts. Yeah, so the poor prompt didn't identify that you might just log transform. It didn't identify a treatment by time structure and repeated measures structure. And the most egregious error in the advice, I think, was the appropriate missing data treatment. And that was actually why those people came to see me in the first place, was they weren't sure what to do about the missing data. So the better prompt, it said everything I would have said. It also said a bunch of other stuff that was excessively complicated. It suggested GEEs, and it had like 3 or 4 other more complicated approaches that were just like not necessary. Like and probably that's where it leans towards finding you a complicated solution to what might not be that. But I think that's because I asked it for approaches. So yeah, so I was just wanting to know, like, if you're in the audience here, like whether you would have trusted the AI judgment here. And obviously everyone's got their own level of statistical expertise, but if you're coming in from a relatively introductory level of statistical expertise, you may have just trusted that AI judgment from the first prompt. Yeah, so more prompting techniques is to ask about competing methods to avoid sinking into an echo chamber. And you can also challenge AI to critique your methodology and act as a mean reviewer. So what we could do is go back, tell Claude or ChatGPT, this is what I did, and see if, as a reviewer, it can be like, well, what about that mouse that's had cancer that you just deleted? You know, isn't that biasing your results and your treatment effect? I haven't done that, but it would be interesting to see if it could have picked up that methodological flaw. And then the other thing is that if you do start with a prompt that's not got enough context and you realize that in the responding, then you want to regenerate the response, adding in the context. So this iterative nature of prompting is meant to be quite important. Yeah. Okay, so that's, yeah, the first one is garbage in, garbage out. The next failure mode, I think, is blind trust. And I guess this is, this is a really key one, because we all know AI can hallucinate. And the most dangerous outputs are the ones that they sound correct, but they're actually plausible nonsense. So it might have hallucinated reasoning, strong judgment calls, incorrect statements of assumptions. These are all things that can happen in like statistical, when you're asking it for statistical methodology. It can choose the wrong model. It can invent package functions. It can find a package that does this type really U-Butte kind of model that doesn't actually exist, and it can misinterpret outputs. So the practical recommendation is that you really do need to verify everything. So yes, use AI for acceleration, but not authority. So this means like you do have to read the code. You do have to check references. So if it gives you a methodology that you haven't heard of, or it's a bit outside of your expertise, you want to do some reading outside of an LLM about it. If you're lacking training to sort of verify this methodology and read the stuff about it, this is when you want to maybe get some training or collaborate with someone who's sufficiently trained. And I'm sort of thinking about this because I know we all hear about all these software companies that are not doing any coding anymore. They're just using LLMs, but they do have software engineers who know how to code, who are supervising all of that LLM generated code. So if you don't know how to code, you need to actually learn enough that you can verify what you're getting back from an LLM. And you need to check diagnostics and model assumptions. So if you're using a statistical methodology, there's always assumptions, there's always diagnostics. So you need to be like finding out what they are and checking those, not just running an analysis pipeline without any oversight. Don't outsource your thinking. These things, they do need a brain behind them. So this is just a little example. This was my son's favorite slide in this talk because it was the only one he could understand. But I told AI, change the leaves to be orange, keep everything else the same, but change the branches to be blue, and make the tree shorter by a few branches. And I gave it to ChatGPT 5. It did a pretty good job. It kind of just shrunk the tree rather than made it shorter, but the branches are definitely blue. It's a bit shorter. I gave it to Claude, and this is literally what it did. And yeah, it's a shorter tree. It wasn't quite what I wanted it to be. I could look at that and, in milliseconds identify that this was the wrong thing. But if I was blind, I wouldn't know. Claude would say, thank you, I made your tree shorter and here it is. And I'd just be like, cool, it did what I asked. So that's what doing statistics could be like if you don't have statistical training. I've just realized that is not showing you the whole slide on there. Sorry about that. I don't know if there's a way to fix that. Most slides, it's not a problem. Yeah. Okay, so so the tree example is very accessible. Here's a less accessible example. So turn your brains on. We're looking at a residual plot. So hopefully you know enough statistics to know that there are these kinds of things called residual plots that you use to check model diagnostics. That's all you need to know. I got this plot, I actually found it on the internet, and it's a diagnostic plot for a model. I asked Claude Sonnet 4.6, is this residual plot okay? And it gave me all this stuff. So without going into all the details. It kind of like correctly describes this plot to me. It describes fairly correctly what's going on. It describes that there's these ugly red lines that mean something wrong. There's these p-values of 0, which means there's significant deviations from some of the model assumptions. That means this data might not be I'm trying to think of the word. The data might not be matching this model. Yeah, so zooming in on the title of Claude's response, this one has real problems. You're a mere human. How do you feel about your model now? I asked this same question with also no additional context to a few statisticians, and I got a few replies. Yeah, and so these people replied independently to me, but they are all people that work in the same group, so they talk to each other. Their responses are a little bit similar, which is interesting, not as independent as I thought. Got a bit of a cluster bias here. But these first two responses, they both said the same thing. They want to see this plot generated in a different way. So they don't like these 0, 1 residuals that come by default with this package, Dharma. It's hard to see what's going on. Yeah, this other person, I don't like the look of that, but I would like to see it mapped onto the Gaussian normal scale beforehand. So they both want to see the diagnostic plots in a different way before they can make up their mind. And then the third statistician, similar thing. They also don't like this plot. They want to see it in a different way, and they want more context. And you'll note these responses are notably human. They're from busy people, answered on a Tuesday morning. So thank you very much for helping me collect some data. And this person's also identified that it looks like there's lots of data here. And so when you get lots of data, you tend to get these significant p-values all the time, and it doesn't necessarily mean that there's a important violation of the assumptions. Actually, this person wouldn't rely on these tests at all, blah, blah, blah. Definitely a human. And a final response I took from Stack Exchange, because that's where I got this plot from. And I'm really sorry. Is this online? Is it like this? No, it's only the people in the room that are getting this truncated slide. But I'm going to summarize the text for you anyway, because I don't want you to feel like you have to take all of that in. But what Florian said, he is the developer of Dharma. That's the package that made these plots. He has also been very humble. I don't have the final wisdom regarding the interpretation of residual patterns. And Florian's also said, look, those significant p-values, they're not really a problem. What you should be looking at is the magnitude of the deviation, and his judgment call is that it doesn't look large enough to cause major concerns regarding inferential products such as p-values. And he's also suggested you could do some stuff. So just to summarize, Claude, you've got real problems. We're going to have to do something about this. Statisticians, look, it could be okay, actually. I want to see the plot in a different way. And most of those red p-values, they're not the important ones. The assumptions are not that important that are being tested there. So your model's probably fine. And also, yeah, like test result, these p-values and stuff, you don't need to focus on those so much when you're checking a model, diagnostics, and some more context. So the thing about this example is that I did not think that AI answer contained any obvious hallucinations. All of that text it gave was actually quite factually accurate, but its judgment was off. So in assessing the residual plot, you had to make a judgment call. A lot of statistical decisions do end up kind of being judgment calls. And that's where I think AI can do quite poorly. It's going to make it for you, but whether you trust it or not is another thing. And I'm not saying it's always wrong. I've intentionally included an example with a mistake. But yeah, would you have trusted the AI judgment here? I don't know. I might have if I wasn't trained if I hadn't looked at thousands of these plots before, which I have. I might have thought, I'm going to have to fix this model. Because I'd say most of what the statistician said, it was quite subtle, their feedback. So yeah, so that's the end of failure mode 2. So you want to verify everything. So because it's not always obvious what's wrong with the response. Now, the last one is over-automation. So if you overly automate your analyses without oversight, you can get this thing that's colloquially known as AI slop. So this, in the context of statistics, it tends to mean like large volumes of code that hasn't been checked, generated really quickly. But it can also, you can get AI slop that can be text as well. And this, I think, happens because of over-reliance. So if you can't edit your own code and you're regenerating code from scratch to change something quite small, that feels to me like over-reliance. And you can get into this situation where AI becomes one big black box. And it's like, here's my stuff. Here's my research question. Get it back. Oh, I've got to change something. Chuck it all in again. Get it back. So that feels like an overly automated workflow. And another danger that you can get here is intent drift, where your AI actions gradually diverge from your original goal over a sequence of small steps. So yeah, there's small interpretations often compounded. And this is the sort of well-studied thing. So before AI, coding could be a big bottleneck for some people. Slow, get errors, it's hard. But now that's actually not that hard anymore to get code, but verifying it is still a bit of a bottleneck. So the practical recommendation for sort of not over-automating is to keep humans in the loop. And by humans, I mean, like, you are a human and you want to keep yourself in the loop. So you want to ask AI to help with itemized steps, which you can iteratively review and edit. If you break it down, you don't have AI slop that's so big that you don't know where to start. This means if you aren't an expert in the thing that you're doing, you can also acquire expertise at a rate that is possible for a human to take it in. Also, you can keep a statistician in the loop because statistical thinking does become more important when the analysis is becoming easier. Still need to make sure you're doing the right analysis. And I'd really ask you to do this iteratively with anyone that you're working with, maybe not a statistician, but someone else in your research team, is you want to get help in an iterative way before you have reams of analysis it could have intent drift, it could be wrong from the start. And so if you get help even if you're using AI to do each step, if you're getting help along the way, you can sort of have that verification built into your workflow. And if that verifier is yourself and you're qualified for that, that's also great. So another thing you can do here is to save your AI conversations related to each project. So if you have prompted it for a methodology for a particular project and it's told you to fit a particular kind of model, if you have that conversation history, someone else can have a look at your prompt and say, oh, look, you didn't actually tell it about all our missing data and you didn't tell it this. And you're like, oh, yeah. And that's why it didn't give you a method that accounted for that stuff. So it can help you to prompt better. And for coding tasks, if you save the conversations which generated the code that you use, it actually just helps anyone that's working with that code to understand what the code does or was meant to do. Yeah, and how likely it is to be right. So I'd say in collaborative environments, sharing your AI conversations is going to become like a part of checking each other's work. Yeah, and learn enough R to be able to read what AI has given you. So that is going to keep yourself in the loop. Yeah. So we need to prompt better, verify everything, keep humans in the loop. And so I think it helps to think of AI as a very fast and rather prodigal junior assistant. So your junior assistant can suggest stuff to you, explain concepts, collate information, draft code, automate repetitive work, and do heaps of stuff. It's great having a genius that you can ask to do things for you, but you are still on the chopping block. So you've got to define your research question. You've got to be accountable for the statistical reasoning when you're choosing your analysis strategy, checking your diagnostics, interpreting results. You've got to be accountable for the coding accuracy. And yeah, basically you're accountable. What about SPSS? This is my final slide. I talked to a few different people about this, and most people I know have not found AI helpful for implementing workflows in SPSS, expletatives used. I tried to do this for hours, get ChatGPT to show me how to do this in SPSS, and I just couldn't. I asked blah, 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 and they did it in like 3 seconds, and then I knew how to do it. So there's less of a reproducibility culture in SPSS. So studies using SPSS don't publish their code. So there's not as many like Git repositories, this online footprint that R has to learn from. So the documentation for SPSS, look, I don't think it's that easy to understand, and Claude agrees with me. So it's just not that easy to fit a mixed model in SPSS. So it's complicated. You need to know what you're doing, and there's not a lot of examples to learn from, or the examples tend to be videos, and I'm not sure if they're going into the large language models. So right now, it feels like getting AI to help you in a coding statistical place is more robust than SPSS. That's for the actual implementation. It can still tell you to do a mixed model, and if you know how to do that in SPSS, like that's okay. But yeah, like actually telling you what menus to go to is way more likely to get it wrong. So it might tell you to do a mixed model, which is the right thing to do, but then it might not give you the right menu prompts to actually fit that mixed model correctly. Whereas in R, if it tells you to do a mixed model, it probably gives you the right code to do the same model. Yeah, so this is my final slide. AI is expanding who can do data analysis. The tools are getting better and better. I actually, as a little anecdote, I used Claude to generate the examples for this talk, but I found that ChatGPT 5, it was harder to get mistakes with. So when I asked very simple stats questions that I actually got the prompts from AI. I said, give me some prompts that are going to generate mistakes that I can use in this talk. And then I put those prompts back into ChatGPT 5, and it just gave me perfect answers every time. I was like, you know, asking it for fairly routine things because I didn't want to introduce a lot of statistics in this talk. And yeah, so the tools are getting better. This is great. Statistical thinking is still this really important safeguard that is turning analysis into science. So stay accountable. And another plug for StatFest, where you can come and talk to a human bot. We've got free drop-in stats consultations, and we've got also lots of talks on really interesting things like causal inference and study design and variable selection. And I talk to lots of humans, actually, many lunchtimes and coffee breaks to sort of like organize my thoughts on this talk. So thank you for everyone for those conversations. And also, I did use ChatGPT to help me structure these slides. I gave it like all this dot points, and it gave me a bit of a talk structure. And that's how I used AI today for this talk. So, yeah, thank you very much. Yeah, do people have questions? I feel like I have lots of questions for you guys, like how you're using it. Yes.
Fantastic tool.
Yeah.
So your example about the residuals.
Yeah.
I just wonder, the problem with that is that there was no iteration.
There was no
You get
iteration.
things to do and you get it.
That's right. Yeah.
If you'd gone back to it and said, you know, are there plots that I'm missing that would help me get to this answer? Probably within 2 or 3 iterations, you can get to something that's much better.
Possibly, yeah. And you know, I will go and conduct that experiment. I'm very skeptical it would have said the same thing that the statistician said, because that stuff is not on the internet. Like the stuff that those statisticians are saying, it's like in a Slack chat that we all use, and we talk to each other all the time, and we are like sharing this information. But the thing about checking model assumptions is that no one publishes that stuff.
Mm-hmm.
Like no one says, this is what I did. It's a footnote in your methods. And so there's not a lot of training data for checking model assumptions. And even when I'm working with people, I'm like, okay, yeah, I'm happy with that model. And they're like, what do I do with all this stuff that we just did? I'm like, just keep it so that you know you did it. Like it's an ethical kind of integrity thing, or put it in the supplementary and mention what you did, but you don't tend to publish those plots. You don't tend to publish the code for how you checked your model. In my experience, correct me if I'm wrong and you're doing that, but I don't tend to see people doing that in the people that I work with, because it's not part of your important research question and the narrative. It's really like background information in the methods. So I actually really don't think it would have told us to generate the plots in the different way that it probably would have picked up on the sample size thing. I think you could have, but you would have really had to know what questions to ask it. So I think I could have got it I could have reprompted because I'm fishing for that information. But if you didn't know to fish for that information, then that's where I think that you don't get it. Yeah. And yeah, that's where the prompting and knowing what you need to ask is just so important. Yeah.
I had a question related to that. Because AIs are normally convincing by nature. Even if they are wrong, they only want to convince you that they are right.
That's right.
It's like
Yeah.
politicians.
Yeah.
And so, do you reckon that if we start a question by asking the AI to identify gaps in our question itself, would it be helpful? Would it be more? Maybe I want to know something
Yeah.
more about you.
Yeah, I actually think I've thought of this before. Like, you could ask AI to ask you what questions what questions you should answer in your prompt about something. Yeah, if that makes sense. So like, yeah, what I'm doing a statistical and a research study, like, what do you need to know to recommend a statistical method, and then go through and I've actually shared with people, like, this is a template that I send to people before a stats consultation. I ask for all this information about your study so I can just get my head in the right space and know what hard questions you're going to ask me so I don't seem silly in the meeting. Yeah, and then well, you could use that to prompt your AI as well, because that's kind of, yeah.
There are a couple of comments here in chat.
Oh, okay. Yeah. I'll just see what's in the chat. So
Maybe when you look at the comments, I can comment on what you
yeah.
said. Something I do is I have something set up where I ask the AI why people to do this in Gemini, I guess not, but can do it anywhere. I think where I've got saved instructions for it to improve my prompts. And so I give it a prompt, which is maybe not that great, ask it to improve it, and sometimes it will just do that, and sometimes it will ask more questions to clarify.
Yeah.
And I think that then those improved prompts give me better answers. I mean, I haven't really looked at that systematically in a while, but so I do think that that's a good strategy, and I do think that you can actually use the AI tools themselves to help you do it. So
Better questions for that.
yeah.
Yeah. The conversation. Yeah. Yeah. I was just saying the conversation in the room for the people online is that it's about using AI to help you reprompt and going through an iterative process, which I didn't do in those examples. Yeah, so I agree that if you reprompt, you'll get better answers, and that should be part of your process. But you still need to be able to verify what you're getting. I've had people come to me and be like, I'm just prompting, and I don't know what I'm doing anymore. Like, I'm fitting this Bayesian hierarchical model. I've got all these diagnostic plots, and then I change something and I ask questions and it's all working, all the code's running. I just don't know what I'm doing. And yeah, that's great that they came to see a statistician, because like, I can ask a few questions like, oh, I don't know. And so if you've gone into a space of like extending yourself, which it's extremely natural to be doing that. And I'm not discouraging you from like doing more modeling. I think it's great that it's enabling more modeling and making it accessible, but you do need to have to have like that level of oversight to understand if you're getting good answers or not. And so that might prompt you to get more training in a particular area because you've decided you're going to learn this thing that you got from AI. Cool. Yeah, that's I might have to leave this room. Yeah. Pardon?
There should be a lecture.